Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about separable differential equation. It seems not separable. So I'm going to discuss the three differential equations in this video. So the first example, xy dx plus 2yx squared plus 4x squared minus y minus 2 dy. It seems not separable, but can be solved using separable method. So if the first one, xy dx, and the second one can be simplified, can be factored. So if we look at here, the first one, this one, I can take 2x squared common factor out, 2x squared. Then I have y plus 2 from the first one, minus, take the binomial aside, y plus 2. So this is the factoring, the first simplify this polynomial in this way. So I'm repeating again, x squared, and here this x squared, 2x squared common factor, left y, the red one, plus 2. If you multiply 2x squared y, so you have the first one, 2yx squared, and you multiply 2x squared by 2 before x squared. Then the second one, minus y minus 2, take minus 1 out, so left 1 plus 2. Then see, this one is all dy is the same, which is equal to 0. Now, y plus 2 is a common factor from this side, y plus 2, this one, and this one. Take y plus 2. Left, I have from the first one, 2x squared minus 1 dy equal to 0. So the first one, the first part, so xy dx. If we look at here, now this one can be separated. So now I have here xy, okay, dx, xy dx. This one, I can move to that side, and I can write it in this way. This one is equal to this part, okay? This one, I can move it to the side here. So will be minus xy dx. And if you this one, the same side, so I have here y plus 2 multiplied by 2x squared minus 1 dy. Then, if we look at here now, in this differential equation can be separated. See, I keep y plus 2, okay, here, and divide by 2x squared minus 1. So here we have 2x squared minus 1. See, by cross product, I'm back the same. And still I have dy, divide this side by y, and divide by this equation by y. So we have over y, and I keep minus x dx. If you look at, if you multiply cross product, y plus 2 times 2x squared minus 1, this one by this one, okay, dy, and y by minus x dx. Then, see, then this one can be integrated, but first also can be simplified. See, look at here, the first one, I can rewrite it, this one, I can rewrite it, okay, can rewrite it 1 plus 2 over y divided by y dy, which is equal to minus x over 2x minus 1 dx. Now find the integral, because it's already separated. Now the integral of both sides, take the integral of both sides, the integral of the left equal to the integral of the right. Now the integral of 1 is y, because this is dy, plus 2 ln y, plus 2 ln y, equal to, now the derivative of 2x squared, the derivative of this one, 4x, we have negative x. So multiply by minus 4 and divide by minus 4. So take this negative out, divide by 4, and multiply this x by 4. So it is the same, we have minus x, if you look at 4 with 4 out, over 2x squared minus 1 dx. Now this one is equal to negative 1 over 4, and the left side is the same, y plus 2 ln absolute value of y. Okay, so, and will be equal to negative 1 over 4, 1 over 4. The derivative is 4x, is ln 2x squared minus 1, okay, plus constant plus c. So this is the answer of the first one of this example, the answer of this example. Which example? See, the example is, again, we have xy dx plus 2yx squared plus 4x squared minus y minus 2 dy. It seems not separate, cannot be solved by separable method, but can be solved if you factor, if you simplify. Example number 2 here. I have example number 2. This one also, it seems, here cannot be solved by the factoring, and cannot solve by the separable method, but can be. If you look at the numerator here, if you look at the blue one, I multiply blue one, the x, I can take x out. So here the solution, dy dx equal to, okay, so let us take this is x, the numerator, x is out. So then we have inside, I have y plus 3. I have y plus 3. Y plus 3. And take this term as the first and the second. Take x out, will be y plus 3. Then this minus out. So if I take negative, this negative one out will be 1 plus 3. So it will be here minus, I have here y plus 3, y plus 3. Okay? Over, again, now this one, I have here xy dx. Again, x can take x is a common factor. I can take x, the denominator x is a common factor. Okay, so then I have y minus 2. I have y minus 2. Y minus 2. Plus, then I have here plus. Take 4 is out. 4 is out. Left here also y minus 2. Y minus 2. See, now look at the numerator. I have y plus 3, y plus 3. Can take this one out, factoring y plus 3. So y plus 3, okay? Then I have times what times? Left the first one, the first part is x minus 1, x minus 1. Okay, the first, the numerator. And what about the denominator? Again, y minus 2 out, y minus 2 out. See, y minus 2 out. You have this y minus 2, and this is 1 y minus 2. Left x plus 4, x plus 4. So now I have here x plus 4, x plus 4. And this one is equal to, look at here, dy, dx, dy, dx, dx. Now, it can be now separated. This one we multiply by y minus 2. So then I have here y minus 2 and divide this one by x, y plus 3. So it will be y plus 3 here, dy. Multiply by dx, so equal to, I have the x minus 1 over x plus 4 dx in this way. And if you look at this one, y minus over y plus, this one can be divided, y minus 2 over y plus 3. So see, if we divide this one, I have here y minus 2 divided by y plus 1, because the same power, y and 1, which is equal to 1, y divided by y is 1, multiply, I have y plus 3. Subtraction, now this was change this one out, so will be here minus 5. So then the answer, this can be written as 1 minus 5 over y plus 3. See, if you now, if you multiply by 1 minus 5, you'll get this is the same y minus 2 over y plus 3 dy. So this one is dy. Okay, the first one, it is dy. The second one, equal to. Now again, now divide this one, x minus 1, divide by this one, x plus 4. So x by x is 1, multiply, we have x plus 4. Now subtraction, change the sign. So this will be minus 5. So it can be written again, 1 minus 5 over x plus 4 dx, x plus 4 dx. Then the next step, now that's already separated, take the integral for both sides. Can be take the integral of both sides. See, the integral of the left equal to the integral of the right. The integral of 1, now I have 1, so this will be here y minus the derivative y plus 3 is 1, so it'll be negative 5 ln y plus 3, y plus 3 equal to, now the integral of this one will be x, okay? So here I have x, and the derivative of x also is 1, so the negative, the integral will be 5 ln absolute value x plus 4, okay? So a plus constant. I can add in one constant, the left and the right. Now see, this one, I can move this one to the right side. This I can move it here to this side. So then I have 5 ln absolute value of x plus 4 divide by minus, often this is minus, it can be do divide, but first I have to write it, minus 5 ln y plus 3 equal to y to this side, I can move y to this side, will be x minus y plus c. And this one, I can be written as, see, this is 5. 5, now I can write the first part, this is the first part, this one, the first part. See, this part, I can write it as, this one is ln x plus 4. 5 will be power 5, and minus the same here, this is the 5. I can write it ln y plus 3 power 5, power 5, okay? And this one is, okay? So this one power 5, and equal to x minus 1 plus c. See this one, ln minus ln, written as numerator. Now we have here x plus y power 5 over this one, okay? Over y. This is y. This is x plus 4 power 5 over y plus 3 power 5 and equal to x minus y plus c. And this one can be written as 1, 5 can be this one. So ln, I can write here x plus 4 over y plus 3, all of them to power 5 equal x minus 1 plus c. So now take e both side. So e both side for e both side. So that is mean the first one and with e is inverse to each other. So I have here only x plus 4 over y plus 3, okay, power 5 equal e to the power x minus 1 plus c. And this one can be written as e x1 minus y times e power c, which is can write it as c1. So then that is mean this I can write it as I can write it c1 e x minus y, on the right side left to the equal will be this one, x plus 4 over y plus 3 to the power 5. So that is mean this is is the final answer. This is the final answer. E to power c equal to c1, because we don't know what is the c, so it as a constant c1. So this is the final answer of the differential equation. Now this one I have here another example. This example. See, this example, it seems also cannot solve by separable, but can be solved by separable. I got only the first few steps. Here I have dy dx. So dy dx equal to, this one can be written as x y minus 2. So e, I can write it as, see, e to the power 4x times e to the power 6y to the power 6y. This one, 6y. Okay, 6y. And the c, x with x, keep it together. So then this one we have x e 4x, and I have this one together. I have y negative 2 e power 6y, okay? See, now I have here this one dy dx. So now can be solved by the separable method. Now see, look at now the dy, this one dy, divide by y minus 2, and we multiply by y2. So this will be how y squares here. And here I have e minus 6y, okay? E minus 6y, okay? E minus 6y. And equal to multiply by dx, I have here x e 4x dx. And see now this one, y square e to power, take the integral for both sides, integral of the I have the integral of the left equal to the integral of the right. So both of them can be solved by u dv. Okay, you can be solved the integral u dv, and you can continue the answer.